Today, my name is Misha. I'm one of the Seath developers, and today I want to show you some core functionality that were developed for milestone 2 of our Catalyst proposal. All code can be found in Seath GitHub repository under chaining demo branch. There is a detailed description of Seath in repository, but as a quick refresher, Seath is a tool or framework that aims to help developers to deal with UTXO contention problem. And UTXO contention is the situation when we have some protocol that runs on chain, and the state of this protocol is represented by UTXO with datum locked at the validator script address. So to perform some action with protocol, and such protocol can be like swap or auction. For example, to perform a bid for an auction, user will need to build a transaction that will consume the state UTXO, update datum, and produce output with new state UTXO that will be locked at the script address. And the problem is when there are several users who want to interact with the protocol, they will build transactions simultaneously, and all transactions will use single state UTXO as the input. And only the transaction that will be submitted first will be able actually to update state and produce new state UTXO. And all other transactions will fail because the state UTXO will be spent and not available anymore. So other users will have to rebuild and resubmit their transaction and hope that this time they will be lucky enough and their transaction will be submitted first. To mitigate that, Seath proposes a bit different way of communicating with state UTXO. In Seath, users will select the leader, and only this leader will be available to actually submit transactions that will consume state UTXO and produce output with new state UTXO. So instead of building actual transactions, users will prepare an actions, and these actions will describe what users want to perform with this state UTXO. Seath framework will provide a way to describe some actions, these actions, so the actions can be totally arbitrary, and it will be up to developers how to define the actions. So developers will define the way how the action will be represented, and also the way how these actions can be translated to transaction constraints and lookups. And using these transactions, constraints, and lookups, leader will build chain of transactions. And chain will be built in such way that next transaction in chain will use outputs of previous transaction. So when the whole chain of transactions will be submitted, it will produce the sequence of actions on the state UTXO, and at the end it will produce like final state UTXO with all user actions applied in sequence, and there will be no contention between users, and all actions will be applied in the order in which leader will receive actions from the users. For current setup, we use pretty simple contract. The contract state is represented by single number, and each user will try to increment that number. Let's say it will try to add 100 to this number. The protocol is pretty simple, but the issue is still there, because if several users will try to add 100 to the current state, they will build transaction that will use same state UTXO as an input, and again, only one user will succeed with updating the state, and all other transactions will fail. To build actual script, we use Bluetooth and Bluetooth TX, and you can find actual validator code under the off-chain directory and additional validator. Validator is pretty simple. It's just check that data was properly updated, in particular that current value was incremented by the value specified in the redeemer. And for the off-chain part, to build, submit, and chain transactions, we use Cardano transaction library of version 5.0.0. And we have an example of contract that will perform addition. You can find sources in off-chain directory, tests, examples, addition. And in particular here, you can find the description of how user actions are actually translated to script, to transaction constraints and lookups, which will be later used to build transaction chain.